So, hello everyone. Generally I try to avoid oversimplifications, but I think that sometimes it's useful to go out of our system and see what happens in other systems as well. And without oversimplifying, of course. So I will ask you to follow me a little out of the occupation I have the safety system to another system, something more pleasant like taxes, for example. Alright, so can you imagine a taxation system where the taxpayers have to seek legislation themselves, tax legislation, and then according to their findings to calculate their taxes and all, and then pay their taxes and wait to be sample inspected by authorities. Nobody can imagine such taxation system. If it reminds you something, that this is more or less the way that the occupational health and safety system works. What I mean, this system, the ELINYAE system actually, consists of two subsystems, independent subsystems. One system is inspection authorities, and the other system is each individual enterprise at the individual level. Each one of them gathers legislation, have to seek for legislation, to seek for guidelines, knowledge, research, findings, and everything, know-how, all of them. They have to take them and interpret them into safety measures and workplace, independently. Their only contact is some inevitably rare on-site inspections. Each company takes about an average 10 or 15 years to be sample inspected. This is the only communication, the only exchange. Now, how likely is it that these two interpretations will be the same? That's a structural issue. Okay, so what can we do about this? So, our proposal is that instead of having everyone gathering all this knowledge and interpreting them into certain measures, to do this once centrally, opened by the authorities, and produce something like a huge checklist, of course not like this, but just as an example, and have exchange of safety data, health and safety data, online, in real time, through this extended checklist. So the most important part of this presentation, I think, is this one, that we need to have data exchange. Now the way, what kind of data, which form, how frequently, this could be adapted to each system of each country, the way you think that it's better. But the most important thing is to have data exchange. So I could even stop this presentation here. But I don't have 10 more minutes, so I have to show you one way, to demonstrate one way. That's good in theory. How can this be done? So, since it goes for labor inspection authorities, we cannot put a new taxonomy. We cannot put people finding new standards, new taxonomy. So we can use DSL taxonomy of Eurostat, which is the one that all labor inspection authorities use. So, more or less, this taxonomy has a lot of things, like here, mostly demographics of an accident. And then the accident model, the main accident model is like this: physical activity on a material agent, deviation on a material agent, contact and mode of injury on a material agent, and then we have types of injury. All of them are codified with codes and everything is written down. So we focused on this stage: contact and the material agent. The contact is the type of injury that happened, and the material agents are the location, the equipment, and the materials or substances that were used. All of them are codified in this taxonomy. So we focused here, and our base is the material agents. So one step is that we put this list of material agents, and all enterprises choose the material agents they use. Of course, in a more simplified form, you cannot take this huge lists, but there are ways to do this. And this is something also very important. Just having the material agents of all enterprises with some coefficients that we have and some weighting factors, that will give us an automatic picture of the risk in each enterprise, of the level of risk. So I could again stop here, but I can stop here. We can do much better than this. So the other thing is what we did in our research, where I should start sometime, is that we tried for a large sample, not all of the material agents of the SAO taxonomy, to gather potential accidents, the list of contact mode that is related to this material agent. So here, for example, we have a forklift truck, and we have some, there are actually more, should be a huge slide, of contacts that are related to this. That was the easy part. The difficult part was to seek in legislation and in practice to see potential measures that are linked to this. So we have a list of these measures for each material factor as well. And then the even more difficult part was to find which one is related to which one. And of course, not directly with some weighting factors, because not all measures are the same importance. So that was a big work behind. So we produced an application, web application. So what the user needs to do is, from the list of material factors, to choose the material factors they have, and automatically the list of related measures is produced. Then they have to tick which one of them is in place, and then the system automatically finds what kind of accidents could happen, what is the risk for each accident, and of course to calculate this. So we can have this online in real time. But of course the idea is not that the labor inspector doesn't go on site, it stays in the computer, it takes each individual enterprise and checks all this. No, this is done automatically. Of course you can have routines. So all enterprises are sending this is the plan, all enterprises are sending this data, complete this, and this goes to central processing, where we have alerts, big risks, big things that are missing, and then automatically enterprises are notified and inspection authorities are also notified, because this system is not to replace on-site inspections, it's just to inform them, so that we could have alerts for enterprises, you're missing this, your risk is big here, or we could have alerts for inspection authorities, go and inspect these people because we have a problem here. And also, to enrich this, there is also a system for reporting accidents. So if an accident is reported according to SAO to this material factor, then we can see in real time. We also report the kind of injury according to SAO, and then we automatically see what was missing, what are the related measures, and which one of them were missing. So we know what was missing in the workplace. So we can actually have a great sample of what was missing and which kind of accident. And this could help machine learning to improve the system. Because we cannot make it perfect, but we could have some data like this. So it could produce many kinds of reports. I just took some screenshots of the software. So one of them is just having material factors with the related possible accidents and some assessment of this and the measures that were missing and the total measures that were missing in this one. But we could also have some graphs like what are the most important risks in enterprise for all material agents. We can compile, we can do anything if we have this data. Or we could have the measures that are missing and how important they are. And this is the last point I would like to mention, which is the kind of measures, because this shows a different mentality. So this system is not a system that every enterprise declares the data and then they're fine, they have to pay is calculated. So we need to have a different mentality in labor inspection to follow such a system. Don't ask people to declare what they're missing, what should be defined. And this is that not all measures are the same. In legislation, it's binary. You have a measure, you're legal. You don't have a measure, you're not legal. It doesn't matter what other measures there are in place. It doesn't matter how important this is. All measures are the same for the law. And this is something that we need to change. We don't punish enterprises because they're missing something. We punish enterprises because they lie, if they lie. Okay? And we also guide them. So what's the value of measure? What affects the value of measure? One thing that affects, of course, is how much it reduces risk. The probability or the severity of the risk. How important it is. But this is not all. Another thing is how many risks does it apply to? For example, a guard actually protects from one certain type of injury. But training could have a lower impact for one material agent or one accident, but it has a wider scope. So it could actually reduce cumulatively the risk in the enterprise more. How large are the risks does it affect? It's different to have a measure for a major risk and a measure for a minor risk. It's not as important. So the size of the risk we're facing is also important. And also if it's complementary or alternatively or combined to other measures, are not independent. So we need to have all this processing. This way, this is just a proposal, or in another way. So that we could actually go to a better view. So measure prioritization is not easy to be performed in QB. We need to have some support for this. Why? Because it's a legal issue. So this is the main difficulty to go in such a system, because technically it's not very difficult, but I believe that in our age, it's very important to have data. We cannot work without data. We couldn't do this in the past, we can do it now. And of course, all this could be improved with machine learning, artificial intelligence. It's much easier to complete such a report than manually. So I hope I didn't take too much time on this, and now I can finish with the presentation. So thank you.